Hey guys,
Hi.
what you doing?
We're studying organic chemistry.
I brought some apples.
Ah.
Do you know that apple contain monosaccharide? It contains fructose.
Oh, really? Milk contains galactose.
Oh.
Oh, so honey contain fructose.
Oh, I see.
I don't get it. Can anyone explain what is monosaccharide?
A monosaccharide is a simple sugar that serves as the building blocks for the more complex sugars such as oligosaccharide and polysaccharide in biology and also biochemistry. For example, fructose, galactose, and also fructose and glucose are example. Monosaccharide is an etymology term that means one saccharide. The unit structure of carbohydrate is referred to as a saccharide. Because monosaccharide are the most basic form of sugar, they are also known as simple sugars. This means that hydrolysis cannot break them down into any further into simpler sugar. Monosaccharide, on the other hand, can combine to create more complex form. Sucrose, often known as table sugar or granulated sugar, is a disaccharide made of two monosaccharides, glucose and also fructose. Monosaccharides are often colorless, crystalline solid, and sweet tasting. They can be dissolved in water and occur as syrup or liquid sugar. Carbon is covalently bond to other atom in them, particularly carbon to carbon and carbon to hydrogen.
I will now explain about aldoses and ketosis. Ketosis and aldoses are monosaccharides that can be distinguished by the group in which they are found. An aldose is a monosaccharide with an aldehyde group in its carbon backbone. They can only be found in plants, while ketose is a monosaccharide with a ketone group in its carbon backbone. Here is an aldose, and its chemical name is glyceraldehyde. As you can see on the first carbon here, that there is an oxygen atom attached with a double bond to the first carbon. There is also two hydroxyl group attached to the third and the second carbon.
So the difference between aldoses and ketosis, which is the position of the double bond of oxygen. For aldoses, the double bond oxygen is at the first or the third carbon, or at the least or at the end of the carbon chain. But for ketone, it is the middle group. For example, here it is at the second carbon. So that is what differs from aldoses and ketosis.
Carbon, also known as the center of chirality, is a carbon atom that is coupled to four distinct groups and has two non-superimposable mirror image. So here is an example. Like we talked earlier, glyceraldehyde, which is an aldose, has two super non-impossible mirror image. So as you can see, the center carbon are connected to four different groups of atoms. So how can we determine which is the chiral carbon is? So this is one different group, one different group, one different group, and another one different group. So there is total of four different group of atom. So this is the chiral carbon.
Isomerism consists of two types, which are structural isomerism, that also known as constitutional isomers, and another one is stereoisomerism. So the first one we have structural isomerism, that known as constitutional isomerism. Structural isomerism has three types, which are chain isomerism, position isomerism, and functional group isomerism. We focus on stereoisomerism. Stereoisomerism, which includes enantiomers and diastereomers. Enantiomers are compounds that are mirror images to each other. The example of enantiomers is optical isomerism, which occurs when monomers have a chiral center and get two non-superimposable mirror images. Next, we have diastereomers. Diastereomers consist of many types of isomerism, such as geometrical isomerism, anomers, epimers, and others.
As explained earlier, stereoisomerism have two, which is the enantiomer and diastereomer. In general term, the stereoisomerism which means that they have two or more monosaccharides which have the same structure, but what differs between these two molecules are its configuration, which is the arrangement of their atoms in the space differ from each other. So for example, we have these two molecules, which is the glyceraldehyde. But what differs between these two molecules are, on the left side you have the glyceraldehyde, which is the OH group is bonded to the left carbon side, and the right side you have the D-glyceraldehyde, which is the OH group is bonded to the right side of the carbon. Next, we move to the enantiomer. Enantiomer is the pair of stereoisomerism which has the mirror image of each other molecules. In regard, they have the asymmetric carbon atoms present in the molecules. So, for example, we have the glucose occurs as a D and L glucose isomer. On the left side, we have the D-glucose, where we can see that the OH group is bonded to the right side of the carbon. Meanwhile, on the right side, we have the OH group of the L-glucose, which is bonded to the left side of the carbon. We are focusing on the ipimers, which is it is a monosaccharide which differ in the configuration around one specific carbon atom, other than the carbon atom of the carbonyl group.
Sugar, apple, milk, contain glucose, galactose, and fructose. No time to talk. Monosaccharide, a simple sugar, it cannot be broken down. Now it's alright, it's okay. You may look the other way. We can try to understand. They can be broken down more than they are. Whether fructose or whether glucose is staying alive, staying alive. See, they are so much changing and they be spinning, staying alive, staying alive. Isomerism, isomerism.